I'm Anil Kumar, and in this activity, we will try to sketch something and write equation for the same. We are actually doing modeling of periodic functions. The question here is, a half cycle of a sinusoidal wave is shown below. Find its equation. Now, the idea is that, there's nothing here you can see. But the idea here is that what you can do is, you can make a question for yourself and then practice. That's the whole idea. So we will just sketch something and sinusoidal function. So we'll say, well, let's say this is my half cycle, correct? Now it is kind of moving like this, so it looks like a sinusoidal function. So what we should do here is we can give a maximum value, let's say, and a minimum value. Let's say the minimum value is 20 and the maximum value is 50. Now we also need to give some value for the x-axis. So we say, well, the starting point, let it be in degrees. So let's say this is 40 degrees, and this point, let us say, is 90 degrees. Okay, that's fine. So this is the angle theta for us, and that is the y value for the trigonometric function. So the idea here is that you can make some graph like this on your own and then practice writing equations for the same, correct? So that's the whole idea. So in this case, what we will do is we'll write both sine and cosine functions. So if you're writing sine function, we can say y equals to a times sine, and general equation is k. X is theta for, I should write theta here, theta minus p, the phase shift, plus q. And if you're writing cosine, you replace sine with cosine and then write. So the cosine function will be y equals to a cos of k theta minus p plus q. Now that is how the function could be, right? Now why have I taken half wave? Some of my students always, when they calculate the time period, they're looking for the x value or the change in horizontal from one maximum to the other or from one minimum to the other. Now here is a reminder. That is, if I have a maximum and a minimum value, then this is half the time period. This is t by 2, right? So you can also find k from this half the time period and write the equation. So at this stage, you can actually pause the video, answer the question, and then look into my suggestion. Okay, here is how we are going to do it. So whenever you have a graph here, list what all is known to you from the graph. So we have maximum value. So maximum is 50 for us. Minimum is 20 for us. Time period is what? Time period should be twice this distance. This is 2 times, let me write, 90 minus 40. 90 minus 40 degrees, right? So time period is 90 minus 40 is 50. So we get t of 100. All this is known to us, correct? But this is enough to get us the equation. Now let's see how. When we do know maximum and minimum, we can find the amplitude by finding their difference and dividing by 2. So let's do our calculations now and then see different kinds of equations which we can write from the given situation, right? So let's begin with A. Amplitude is maximum minus minimum divided by 2, which is 50 minus 20 divided by 2, which is 30 divided by 2, 15. Now the axis, which is q for us, right? So which is the average value, maximum plus minimum divided by 2, 50 plus 20 divided by 2, 70, half is 35. As soon as you get this answer, sketch the line at 35, which should be somewhere here, right? So let's say this is my axis and it looks okay. If this is 35 plus 15, yes, it gives me 50, minus 15 gives me 20. So it is a good checkpoint. When we find, well, this is perfectly fine for us. So we are clear about these two values. Okay, now let's move inside the function. inside means horizontal. Till now whatever we did was vertical, right? So this is vertical. Okay, now let's get to horizontal things, starting with the time period. So when we know time period is 100, so we can find the value of k, and k is 360 degrees divided by 100, which is 3.6. If you are doing it in radians, then it will be 2 pi by 100, correct, or pi by 50. So in radians, that is the value of k for you. Anyway, and the last part for us is the phase shift. Now, phase shift is starting point. If I'm writing equation as a cosine function, for example, right, in that case, we are starting from minimum. We can always write this as negative of cos, considering this point. If you consider that point, then we have a phase shift of 90 degrees. Do you understand? So either way, it is good enough. So let us write down now. So about phase shift P, if it is a cosine function, let me write cosine function. In that case, the value of P could be, I should write 90 degrees actually, or I could write P as, for a negative cosine, it could be 40 degrees, right? So that is for the cosine function. If we are considering the sine function, then the sine function starts from the middle of this value, right? So midway between them is how much? Now, since the difference is 50, we have to add 25 to get midway, which is 65. So for sine, the value for phase shift is 65 to the right. You get the idea, correct? Now with this information, we can write a couple of equations representing the graph, right? Let's begin by writing the cosine function first. So y equals to a is 15 cos k we calculated as let's use 3.6. Let's do it in degrees, okay? Times theta is my variable along the x-axis minus p. So I could use minus 90, correct? So that is the maximum. So cosine will, we are assuming that it's going to go like this, correct? So that is the point, minus 90. All this is in degrees, correct? Plus this axis of 35. That is one way of writing it. The other way could be, we could think this is the starting point. So it's negative of cosine without any phase shift, right? So, I mean, the phase shift is 40. So negative cosine with phase shift at 40, right? This is what we are considering. So we could write this as negative 15 cos of 3.6 theta minus 40, right? All this is in degrees plus 35. So likewise, we can give two cosine functions. Now let's write down the sine function, which is y equals to 15 sine of, if I want to write it in radians, then k value is pi by 50, right? So we'll write pi by 50 for those who want to write in radians. For those who want to write in degrees, they should continue with 3.6 theta. And this value will be t over 2, 65, right? So let me write minus 65. And then we have this in radians, plus 35. So that is how you can write your equation for sine function. Remember one thing, that when we are given a minimum and a maximum value, then the difference between the two is half the time period, okay? That should help you to get the right answer. So this half the time period was 50, so the time period was 100. And then we calculated the rest of the things as we normally do. I hope this example helps you to understand how to find equation. Also, more important, how to just sketch a graph and find its equation. That will give you a lot of practice. I hope that helps. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.